So once we have that, how do we determine our max and mins? Do we remember that? What do we plug in? We plug in our...
1, -1, and then up there.
So we plug in our two endpoints. I'm going to write them like this. And then we plug in our critical values. And you don't need to get your calculator out. I think we'll stop from there so we can just keep going. You understand what we're going to do from there, right? You plug all those into the original. The biggest one is your max. The smallest one is your min. There you go. Okay. So do we remember that from before break? Because we're going to use all of this and keep going with it with what we're going to do today. Okay. So find the critical points. Find the derivative. Find the derivative is 0 or undefined. Okay. All right. So what we're going to look at today, increasing and decreasing functions. All right. Sometimes I do this in different order. We just did this yesterday, so you guys all remember the mean value theorem, right? We just did that yesterday. So we have this. Basically, it says if you have some curve, there's some point where the slope, the derivative at that has the same slope as the line between the two endpoints, right? We did that yesterday. All right. We're going to use that here in a second. So let's talk about increasing and decreasing functions. Let f be a function defined on an interval. Let x1 and x2 be any 2 points in the interval. Now, as we go through this, as we do this, these are any 2 points. And it says it down here, but I'm just going to kind of say it here from the start. We're going to always assume x1 is greater than x2, just so we kind of have the same notation going through. What's that?
You just go x2 is greater than x1, you said x1 is greater than x2.
Did I say it backwards?
Yes.
This is what we're going to do. x2 is always greater than x1. We're just going to arbitrarily say x2 is the bigger one, x1 is the smaller one, okay, for any 2 points. Okay. Now, and once again, this makes sense. This is somewhat intuitive here. If x2 is greater than x1, we're going to say that, and if f of x2 is bigger than f of x1 for any 2 points on the interval, the graph is increasing. It's going up. Earth-shattering math, right? If f of x1 is greater than f of x2, the graph is decreasing. There's no calculus there. That's just definition of what increasing and decreasing functions are from algebra and math in general, right? As you're looking at something from the left to right, it's going up, it's increasing. It's going down, it's decreasing. Kind of like positive slopes going up, negative slopes going down, same idea, right? Now, you may have a graph like that where there's different parts, right? This part is increasing, this part is increasing, the middle is decreasing, so it can change. Make sense? Okay. So we're not saying the whole graph, that's only a line that would be that way. All right. So let's consider this part right here from the mean value. And this is not in your notes. You can just kind of watch here for a second. We're gonna have a theorem down here, and I'm gonna kind of build up where this comes from. So this is from the mean value theorem. Saw it yesterday, right? We rearrange it a little bit. If I said this is f prime of c equals x2 minus x1 equals f of x2 minus f of x1. So far, so good? Does everybody see how I got that? Okay. If I look at this part right here, what do I know about x2 compared to x1? Bigger. So that value right there, what is the SIGN sign? Positive. This is always positive. So when we looked at the sign analysis, if something is always positive, what can we do with it in the sign analysis? Get rid of it or not worry about it. Which that tells us that this and that. Now, this is a number, right? This is number. So I'm not saying they're equal numbers, but the sign, this and this, have the same sign. Because this is always positive. So if you think about it in our sign analysis that we did back on Monday, whatever the sign of this is, this has to be the same sign. Make sense? So what does that tell us? Well, if it's increasing when this is true, if it's increasing, is this positive or negative? So if this, let me rephrase that. So if it's increasing, f of x2 is greater than f of x1. So what is f of x2 minus this? It is positive, right? So this is positive. Which means, what about the derivative? Also positive. If this is true, that means it is negative, which tells me that this is negative. Now, once again, we just proved this using the mid-value theorem. You already know this instinctively, because if I go back to here, what is the slope? What's the derivative of this if it's increasing? Positive. Right here. The derivative of the increasing red part is positive. If it's decreasing, the derivative is negative. So we can determine our increasing and decreasing functions by this. If our derivative is positive, it's increasing. If our derivative is negative, it's decreasing. Now, think about what we did on Monday. We did a sign analysis, and we determined where something was positive and negative. That sign analysis is going to tell us where increasing and decreasing parts are. Okay. So let's kind of put all this together. Really, this is all stuff we've already done. It's just kind of combining it in a new way. Excuse me. All right, so find where f of x is increasing and decreasing. This is in your notes. Step 1, find the critical points. Which step? Every problem we're going to work on in like the next 2 weeks is going to be step 1, find the critical points. So find the critical points, take the derivative. So if we take the derivative, we get 2x cubed minus 2x squared minus 4x. And sometimes the functions in these problems may look a little messy with fractions. That's so when we take the derivative, the algebra becomes easy. So to kind of work it out. So now we have to find where it equals 0. Find our critical points, which is going to mean we're going to test your algebra skills and your factoring skills. What can I factor out first? 2x, and then I'm left with x squared minus x minus 2. And we get two numbers that multiply to give me negative 2, add to give me negative 1, negative 2, and a plus 1. Okay? And so, what are my critical points? Negative 1, 0, and 2. You could say them in any order. I write them, I try to write them if I can in numerical order so it works out, okay? So, we got a polynomial, so we're all good. So we've done that before. That's find critical points. That's what we just did. That's what we did before break, right? Find the derivative, find critical points. We did, right? We reviewed that earlier. All right. Next, for Monday, sign analysis of the derivative. So we have 2x, x minus 2, x plus 1, and the derivative. So we do our sign analysis. This is why I write them in order. We have to put, these are the number line. These numbers across the bottom have to be in order. So, for 2x, the way to want to think about this, I'll just kind of reiterate what we did on Monday, is what makes that 0 is right there, right? So everything is going to change if it changes at that point. So, less than 0, 2x is negative. Greater than that, it's positive. X minus 2 is at 2. Less than that is negative. Greater than that is positive. X plus 1 is at negative 1. Less than that is negative. Greater than that is positive. Now we're multiplying those three factors together. Negative times a negative times a negative. Negative is positive. Negative. Positive. Stop there, make sure everybody understands where we're at. Okay. So, if we want to know where this graph is increasing and where it is decreasing. It is increasing when? When our derivative is positive. So that's here and here. It is decreasing when it is negative. So, well, in this case, does it matter if I put in a 0 or not? If I put in a number in, it doesn't really matter because there's no 0 on the bottom kind of thing. Now, think about this for a second. Now, first off, so we're all on the same page because I don't like to write down a lot of stuff, and most of you are lazy also, so we'll all be saying this together. I am never going to write down increasing and decreasing again. So we're all on the same page. What I will do going forward is I will just, get this out of the way. Instead of saying increasing and decreasing, I will do this.
Alrighty.
So instead of saying increasing and decreasing, I will just use the up arrow as increasing, the down arrow as decreasing, and we'll all agree that that's what we'll do because it's just easier than writing out the whole word. Okay? Now, think about this for a second. If this is decreasing, it's doing what? Going down. If this is increasing, what's it doing? If this is decreasing, so we're going to get to this more tomorrow after we make sure we understand this. If this is going down and then up, what happens at -1?
0.
The derivative is 0. In terms of the original graph, it is a, what's that? Well, because it's going down and up, we know it is a valley. You're right. We know it's a valley. If this is going up, then down, we know 0 has to be a peak, and that this is going down and then up, that's got to be a valley. So this connects with your idea of brackets or parentheses. Generally speaking, we just use parentheses, and here's why. What happens at 0? It's the peak. So are you increasing all the way including 0? It's kind of like, this becomes more of a philosophy question than anything else, right? How far can you walk north? Can you walk north forever? Okay, we'll assume you can walk anywhere on earth. You can walk on water like Jesus. But besides that, if you can only walk north for so long, and eventually what happens? You lose your phone? Eventually you're going to go south, right? So that's the idea here, why we don't use a bracket, because at 0, including 0, it's not increasing or decreasing. It's actually a maximum in this case. So that's why this is all parentheses. We're going to add the second part to this, which we kind of just talked about there, and get into a little bit more, is the idea of using this to help us find maxes and mins as we go. Okay? All right. Try another one. Flip it over the back. You try this one. You can find max and mins. Step 1, find the critical points by taking the derivative. All right, let's see. What was our critical points? Our derivative is 3x squared minus 6. So 3. Oh, that's not a critical point. That's our still a derivative. Is 3x squared minus 2. So our critical points were plus or minus square root of 2. There's no 0 because we didn't factor in x. Before we factor in x. It just doesn't work. So 3 is there, but it doesn't affect the critical points at all because there's no x there, like when you said 0. Okay. So now we do sign analysis. How'd you do sign analysis?
I did. I looked at it and I said,
There was only the one.
Oh, okay,
Yeah,
I
that's true.
distracted.
I didn't know if you could put the 3 there or not.
For the sign analysis,
Yeah.
think of it this way. 3 in terms of the sign analysis is always positive, so it doesn't affect the sign analysis, so I'm not going to worry about it. Now, there's 2 ways to do this. One, we could try to factor x squared minus 2. And you could try to factor it into x minus the square root of 2, x plus the square root of 2 to get that. I would not do it that way. What is this shape? What kind of graph is that function? It's parabola. So I'm going to do this as just saying, we're smart enough. I'm going to do this. My zeros are minus the square root of 2, square root of 2. The general shape of a parabola is this. So this is just positive, negative, positive. Remember, this is the confusing part people have. Let me draw it down here. Looks like this, right? And they think Over here, that's negative. It's going down. That's for the function. For the derivative, is this a positive y value or a negative y value? Positive. So that means it's positive. Don't confuse that. You know what this looks like. What does this look like? It's a cubic, right? I'll graph it in a second on the calculator. So it looks like that. So over here, what is it doing? It's going up. It's increasing. So its derivative is positive. If I would just pick a point, it's going up. The derivative is positive, which is why you have a positive value. Okay. So we get to there. Now, once you get there, where is it increasing? Negative infinity to negative square root of 2, square root of 2 to infinity. And it's decreasing, negative square root of 2. And let me just graph this quick so you can see how all this. You get a graph like that. You can see, where is this peak at? What's the x-coordinate? Negative square root of 2, which is about 1.414, right there. Positive square root of 2, we can do there. From what we've talked about before, this is increasing, decreasing, increasing. So this is a max, peak. That's a valley, which is a min. You get that. So for right now, when we're doing the easy ones, what can you do with your calculator? You can graph them to kind of check if you're doing this right. Can we just graph all of them all the way through? No, eventually we'll get to doing these problems where like you don't have numbers, they're all constants and you're doing this kind of stuff. For those of you that are going on to higher level, eventually you get to higher level calculus where you do this in multi-variables, which is multiple dimensions, which means you can't just graph it. So we won't understand what's going on. Okay. All right. Let's do one more. Squirrel. So, that side of the building always has a float, right?
Yeah.
All right. All right. Take the derivative. Lane.
That's my favorite. Now you put it all over down that.
There you go. All right. Thank you. Thank you, Lane.
Gotta say. You gotta play.
So now we're at that point where we're using the derivative, we're finding critical values, so we have to not just find the derivative, you have to simplify it so that you can find where is it 0 and where is it undefined. You there? So critical points. Where is it 0? 4. Negative 2. Well, hold on a second thing. Where is this undefined? Where does the bottom equal 0? Where does this bottom equal 0? It never equals 0. If you put 0 in there, what's 0 squared?
0.
Plus 4. 4. Put a negative 2 in there, negative 2 squared. 4, that's it. So does the bottom ever equal 0? No. So does that mean, does the original ever equal 0? No, the original doesn't equal 0. So our only critical points are plus or minus 2. Because the original and that never equals 0. Now, when we go to do our sign analysis, the bottom is always positive. What does that mean? Cancel it. We don't have to worry about it in terms of sign analysis. Now, you guys are smarter now. I'm going to look at this and say, what's the top? That's just a, what type of function? Quadratic. So, I do not care if you just do that. If you want to factor and make it look all nice and pretty and do x minus 2, x plus 2, and do all of this, and then do negative 2 and 2, and do minus minus plus, minus plus plus, and combine. Does everybody see what I'm talking there? Yeah. Okay. I am probably not going to do that most of the time. For a simple one like this, where all I end up is a quadratic. Now, if we start getting things with e to the x's and logarithms and other kind of stuff, okay, then we got to be more careful. But for right now, we're keeping it simple because we're just learning how to do this. Okay. So where is it increasing?
Negative 2.
So it's increasing here, here, down there. All right, homework.